All right. We'll jump into a super interesting machine learning project, the customer churn prediction. Let's assume that you own a telecom company. You have thousands of customers, and some of them are leaving your service. That is called churn. The customers leaving your service or stop buying products or stop renewing the subscription. That is called churn. Churn is they are leaving. Your customers are leaving your business. Now, what is your job as a data scientist? What you are going to do? So you need to figure out which customers are likely to leave before they do. The whole idea is right after my customers leaving a business, if I run after them, that is not good. Before even they leave my business, is there any way can I predict which customers are more likely to leave? If I get to know well ahead, I can come up with some action plan to retain them. So that's a proactive approach. Okay, now let's break it down step by step. Sounds good, right? Yeah. Yeah, Priya's questions, but how do we do that? Yes, good question. First, we need data. We need data, lots of it, right? In our data set, each row represents a customer, okay, and each column tells us something about them, like, who they are. The demographic information, something like, this is the data. These are the columns which tells us who they are. What is their gender, customer gender, and senior citizen status, whether they have a partner or dependents, and what services are they using it when it comes to telecom. So are they using monthly charges, total charges, payment method, and so on. Okay? And and how they make the payment. That is what the account information related columns or the features tells us. Okay, so whether they are going to what kind of payment mode, right? The payment method, how they pay, monthly charges, total charge, something like that. Okay, and the most important column is churn. Most important column is churn. This is the one tells us whether the customer left our business or they are still staying with us. Okay, you just think about, right, the telephone company is a bit concerned because of late they could see almost 16 to 17 or 20% of the customers they stopped renewing their services with them. They are a bit concerned. They don't want to wait any longer until more customers to walk out of their service or products. Okay, so in that case, what they do, they take the existing data, historical data. That historical data contains all these information, demographic information, and service details. What service are they using it? What payment methods are they using it? What is the target variable? Churn. Okay, so all these columns contains data in it. They took the historical data. They train the machine learning model. Once they train it, and if they apply that trained model on the new customers, it can make a prediction. So and so customers are more likely, or you give any customers to that model, it tells, hey, so and so customers are risky customers. They might tend to leave your business. And also we can categorize, right? How based on the model output, we can categorize how many number of customers are high risk customers, which means they are going to leave anytime. How many number of customers are medium risk customers, low risk customers. Based on the model output, you can classify them, with the three categories. And those customers are at high risk. You can contact them at the earliest and have a discussion with them, or make a phone call and check with them what is their concern. Are they not happy with the service that we give it, or are they posing any connectivity related issues? Because the broadband connectivity is not good, frequent disconnection is happening, even the mobile disconnection is happening. So find out from them, and if they, if they say something like, your service is not good, I had to make 10 calls because last week I had a internet outage. I called your service person, no response. In spite of calling them 3 to 4 days, no response. Okay, and tell the customer, and henceforth it will not going to happen, and tell them that you are going to give some discount or something like that. So these are the ways that you can convince the customers to retain them, because retaining the existing customers is much more cheaper than acquiring the new customers. Okay, fine. So now that we understood, so we have these up to this, we have input features. We call this the input features. And this is your labeled feature. Something like question and answer. We need to show it to our machine learning model. Like how we give the questions with answers to the students. When you give the questions and answer like input features and label outputs, the model can automatically learn the patterns. That is the beauty of machine learning algorithms. It learns the pattern, it detects the pattern automatically. What kind of pattern? Those customers made more number of calls to our call center. Obviously, those customers, are more likely to leave your business. In the past, that is how it happened. Okay, the models learn this pattern automatically from the all you need to just show the input feature and the label output feature. This is your label output feature. This is your input features. You need to show them to the model. The model will automatically extract the patterns. It learns the patterns. Okay, so what is the next step now? So in this case, right, the next part is predicting churn. So we will build and test multiple machine learning models. So why should I build a multiple model? Before even I proceed with, she asked the who Priya. I will answer to that. Okay, don't worry. We need to test. We will build and test multiple machine learning models like logistic regression and XGBoost and random forest algorithms. Okay, random forest is powerful but complex. XGBoost is one of the best for structured data. Okay, and each model will take customer data as input and try to predict if they will churn. That is the whole objective of this case study. Okay, to measure how well our models perform, we will use metrics like the accuracy, AEC or OC score, log loss. What is log loss? What is log loss? Anybody has any idea? What is a log loss metric? How confident the model is in its predictions. That is what log loss. Lesser the log loss, better the accuracy of the model. What is AEC ROC curve? We discussed in the past session. How will the model distinguishes uh, distinguishes between churners and non-churners? Which customers are going to leave us? Which customers are not going to leave us? To distinguish that, right? We can use AEC ROC. How well it distinguishes the churners from non-churners. Right, and that is what these are the metrics that we are going to use it. Yeah, to answer to Priya's question, why do we need multiple models? Can't I use only logistic regression or random forest XGBoost? That's a great question. See, in reality, no single model is perfect for all situations. Do you agree with me or not? Some models might be better at detecting churn, while others might be better at explaining why customers churn. Okay, by comparing models, we can pick the best one for our business needs. Okay. Okay. Finally, once we have our best model, see, basically we are experimenting with three different machine learning models. We'll find out which model is best. Simple example is analogies. Let's say you are experimenting with three different cars. You decide to buy a SUV model, 8-seater vehicle. You want to experiment three different brands. Maybe right, maybe in the same type of models and same price range, we experimented. Of the three, which one is best? You are going to book that specific car. The same way, what we are going to we are experimenting with three different algorithms: logistic regression and random forest, XGBoost, and then we will take a call. Out of the three, which one is really doing great job? But remember one thing very clearly, just because, let's say, let's assume that logistic regression is still outperforming the remaining two algorithm. What can I do? In that case, why do I need to use random forest and XGBoost? There is slight variance, but still I could see the logistic regression is slightly better than the remaining two. There could be situations you might end up like that. Okay, just park this in your mind. I will come back to you later about this one. Okay, so what we'll do is we'll start with so now what we do, right? Our goal is to train and evaluate multiple machine learning models. And what we need, these are the steps involved. What are the steps involved? So first we start with pre-process the data. First step is ingest the data, take the data, and then you pre-process the data. Having the data is not all sufficient. You need to make sure that the given data is sufficient for you to go ahead and build the model. Make sure that you are collecting more number of data. And then you do the pre-processing. You clean the data. Basically, you're cleaning in case of any duplicate records, any missing values. You need to do some kind of encoding, the categorical variables, because all your features supposed to be input features supposed to be numerical when it comes to logistic regression. Even in the case of XGBoost, it requires all your input features are supposed to be numerical values. Though you have some categorical variables, you can convert it to a binary value or something like that. And then you need to do feature scaling. I explained what is feature scaling. The Z-score is the best one. That is the one we do it. And next one is exploratory data analysis, model training, and evaluation. And finally, we interpret the model. So up to this is a data scientist thing, okay? And the model interpretation is important for the executive members, top management. They do not know the ABCs of data science. Maybe you are very good at data science, fine. But to understand the model output, you need to help them to understand the model output in a way that business people can understand very well, okay? So also, right, we analyze the feature importance and sample predictions to derive business insights. And finally, once your model is doing great job, we deploy it. So you can use AWS Cloud, right? So you can deploy the model in the SageMaker. Also, you can deploy it. You can create an endpoint in SageMaker, or you can use Flask API or Fast API. You can ask it. You can use it to serve your model to the outside world, okay, or to your customers. Now let's dive into the analysis and build a robust churn prediction model. This is where the real game charts starts, and we start to load the data. This is the data set given to my manager. I just loaded the data here using this read.csv. Before that, right, you need to make sure that you are importing all the necessary packages. Okay, I think yeah, it is there here. Yeah, I should have put this one here, but okay, I think while putting this one, I just okay, 1 second. I'll just quickly import all the necessary packages. Otherwise, it'll throw an error because it uses some package, pandas package. Okay, just give me a second. I'll just click on the plus sign here. I just move this up, this cell, and and I will move it one more time. Okay, here I just select this one, and sorry, I just click on this. Okay, here what I will do is I will import all the necessary packages. Import numpy as np. Sorry, numpy as np, and import pandas as pd, and import. I'm using the visualization related packages matplot, lib.pyplot as plt, and next one is the import cborn as sns, and what else? Yeah, import time also I'm going to use it. How much time each type of the hyperparameter takes. Okay, and import time, and from sklearn. Yeah, Bill explain hyperparameter as we move further. Okay, model selection, import train test split. Okay, it's all it's case sensitive, and I'm using grid search CV and the grid search CV. That's all. Okay, and what else? From sklearn.ensemble, import random. If you press tab, it should come random forest. Okay, classifier, and from sklearn linear model, we will use logistic regression also. Okay, linear model, import the logistic regression. And the next step is from scalar. We need to uh, use the matrix. From matrix, import, we have something called yeah, accuracy score. Yes, you are correct. What else? Accuracy score and classification report. What else? Yes, confusion matrix. It's a table. Confusion matrix is a table using which we can evaluate the model's performance. And I just say ROC, AUC, score, and ROC curve. Next one is log loss. Log loss, and finally, to pre-process the data, to clean the data, pre-processing, import label encoder, encoding purpose, okay, encoder, and what else? And import XGBoost, boost as XGB. Let me check any spelling. Okay, here there is a typo. I just changed to XGB. I'm going to hit the run button. Yes, you can use PyCharm or you can use VSC also to write your Python. Since I'm going to plot the charts, this is really helpful, the Jupyter Notebook. It takes some time to import these packages. Look here, the pandas has PD. There is an alias. As stands for alias. Okay, here there is an import name accuracy. There is a typo here. Accuracy. Accuracy score. I just hit this one. Yes, I executed it. Now no more errors. And now I just load the data set. This is my data set. WAFN, USC, something like that. This is the data set. It will read it, using the pandas package. There is a pandas package, right? So pd dot read CSV. This is the one will read this file's content and load it in a data frame called DF. Okay, so the entire file data will get loaded into a data frame called DF in the memory. Okay, and then the next step is data pre-processing. What I will do is I'll just do df dot head to see the top 5 records. We will use df dot head 5. It will give you the top 5 records so that you will get to know what data is there, what columns are there. It's always a good practice. You check the columns, be familiarized with the data. As a data scientist, that is the one you need to do it. Look here, we have the customer ID, gender, senior citizen, partner, dependence. Likewise, right, we have so many columns are there, features, and the churn is the labeled output feature. You can see no, no, yes is there. Right? This is the labeled out feature. So rest of them were like something like a question. The churn is your answer. We are giving the questions and answers to our machine learning model so that the model will learn the pattern automatically from this. Okay, and then it detect which customers are more likely to. It can understand something like with this data, it can understand which customers are more likely to leave or which customers are more likely to, leave anytime, something like that. Okay. Next one is how do you find out the total number of records and columns in this data set? df dot size. This is another simple interview because irrespective of your level, they will ask you these kind of questions. Okay, what is df dot size? And okay, df dot okay, df dot columns. You just want to see the columns alone. You can use df dot columns. Okay, and yeah. So these are the things that you can use it. This is your data frame name followed by the dot and follow the dot, you can specify columns. This is the one will give you only the column names. What are the columns that are available? This is the one size, okay? The total number of rows into columns, the product of that one, it gives us here, okay? Yes. What are the next step? Next step is data pre-processing. Next step, we will jump in here and then we will see how do we clean this data set. So as part of this, what we are trying to do is we are replacing the empty values with NaN, not a number, and then we fill the missing values. Wherever the missing values are there, you need to fill that, okay, and then into the encoding the categoricals. For example, in this case, what we are doing is write df dot columns, and here the categorical columns alone, we are checking it, and then we are filling, we are replacing the missing values, empty values by np dot nan, and then we are filling the missing values by mode, by taking the mode, okay, and then fit transform. Okay, so this step will basically does the encoding on it replaces the missing values. Okay, replace the missing values Basically, that is what it does. And also it does the data imputation. What is data imputation? Replacing the missing values. In this case, we took the mode that most popularly occurring values. We take that most popularly occurring values and replace the missing value with this value. And the next one is the target column name. I just stored in this variable called target column. And now what I do is I'm going to create two variables, very simple, xy. And in this, what I'm doing, right, I just, run through at a high level. Okay, so you don't need much of coding knowledge here. Okay, so here what I'm doing is, right, I'm going to split the given entire data by training and test data set. So the test data set will contain 20% of my entire data set. Okay, and the remaining 80% of data will be randomly sampled. That is your training data set. You just remember any supervised machine learning algorithm, you are going to work on it. The first thing is, right, you need to take the data and make sure that the data, whatever the data you collected contains more volume of data in it, right? More historical data in it. Number two is you do the data cleaning, everything. Third step is you split the data randomly, training and test data set. So here the split ratio is 80-20. 80% of my data or training, remaining 20% of the data is your test data set. So why do we have to split it? With the training data set, we are going to train our model. Okay, we are going to train our model using the training data set. Once you train your model with the training data set, you need to test your model performance, isn't it? See, this model is what it does. It predicts, it makes a prediction. So in that case, right, you trained your model with some data, which is training data set. To test how well my model predicts, you need to apply the trained model on the test data set to check with because you did not show the test data to your model. You just show the training data set. So with my training data set, I train my model. With my unseen data, which is nothing but the test data set, if I apply this, my model, how well it correctly predicts. Okay, so for that purpose, we are splitting the data, given entire data into training and test data set. You can use any ratio. Here, there is an option called test size equal to 0.2. That means 80% of the data will be used for training purpose. Remaining 20% is your test data set. Okay, so there is something called train and test split. That is the one is available your as part of our sklearn.model selection. Okay, now we have split the training and test data set. Okay, and next step, what is the next step? Next step, what I'm going to do is I'm going to, here in this case, I'm using a dictionary here. Okay, here I'm using a dictionary, curly braces, right? So all the three models, machine learning, logistic regression, random forest, and XGBoost, because we are going to train three different models. Basically, we are experimenting it. Like I said, I related with the analogy, like the three different cars. I'm trying to have a trial run, and then I'll decide of the three which one is best in terms of cost, in terms of mileage, comfort, all the things, features. Okay. Similarly, we are going to take these three algorithms, logistic regression, random forest, XGBoost. Okay, and then I store it in a dictionary. Now I'm using something called the for loop here. Okay. So what does this do here? Models dot items. So in this case, this for loop, it loops through each model in the dictionary. The logistic regression, random for XGBoost, and then right. So the name here, okay, and then it loops through each models, and then it fits the model on the training data set. Fit. Remember that in the case of machine learning, fit and predict. You have to remember it. If you remember it, you have crossed almost 50% of the your distance. Okay, so fit is fit method and predict method. In the fit method, what you are doing is you are showing all the input features, the questions, and then the answer, like, of your training data set. With this training data set, you show it your model the input features, and then which is nothing but the question and answer. So, right, so using fit method. So fit method, you are going to train your model. So this for loop, what it will do is it will take the logistic regression. It will train the logistic regression with the input and output features of our training data set. And similarly, it does for the rest of the algorithm. That's all, guys. Next one is predict probability. Okay, for each model, it predicts the probability. There is something called predict proba. This is the one will predict the probability. So you know very well probability values lies between 0 and 1. Any value closer to 1, that means that the likelihood of happening that event is very high. For example, Ashok Kumar, a customer name is Ashok Kumar. My model predicted the probability to Ashok Kumar as point 0.9, which means zero point 0.9 is very closer to 1. That means the chances of that this customer is going to leave is very high. There is a zero point 0.9 probability the customer is going to leave. So now the question is predict proba. You have given the unseen data, fine. And why this square bracket colon comma 1? Here, if you use predict proba, what will happen is it will give you the probability for non-churning and churning. We are interested in predicting only the churners. Okay. Hence, what we are doing is you give me the value. Sorry, this is an index value. Okay. Give me the predicted probability for the churners, not for the non-churners. I don't care about non-churners related probability, and I am very particular about what is the probability Ashok Kumar is going to churn. That is what I'm interested. For that reason only, I'm using this one. Okay, predict proba is the function or the method, that is the one you can use it to predict the probability whether the customer is going to leave or if my model is the predict proba predicts and gives me the probability like zero point 0.9, Ashok Kumar is more likely to leave my business anytime. If my model predicts a probability like Rajesh, the probability is 0.4. That means the chances are very slim that the customer is going to leave. Okay, fine. So next one is the score. We are going to find out the AEC score and ROC score. Okay. So what is this AEC score and ROC score? So basically, right, the ROC AEC score and all AEC, right? This one gives us it measures how well my model distinguishes between churners and non-churners. See, you trained your model with the training data set. Training alone not sufficient. You need to test it. Okay, you are applying your trained model on the unseen data. Good. Fine. Now you need to measure your model performance and using some metrics, isn't it? So that is where we have something called AEC score, ROC AEC score, and log loss. Okay. Using these metrics, we are going to we are going to understand how well my model that distinguishes between churners and churners. Sorry, non-churners. Okay. And log loss, this is the one function is helpful in terms of measuring how confident the model is in its predictions. Okay. So for example, right, if my ROC score is something like, AEC score value is something like 0.78 and log loss is 0.5. Okay. So that means, right, 0.78 somewhat closer to 1. Even the AEC value is also very closer to 1. That means the model accuracy is good. Okay. Let's say the log loss is better. Fine. So for that reason, we are using these things and then we are printing these things. Okay. What is the accuracy is AUC value? What is the log loss value? All the things we are printing it. And finally, we are plotting the confusion matrix. Like human, we make mistakes. Sometimes we might tend to wrongly interpret a good person as a bad person. And the opposite is also true. We might tend to interpret the wrong person as a good person also. Like human, do the misclassification. Even the machine learning models also can do misclassification. So to find out whether my model did the misclassification or not, we use something called confusion matrix. Okay. And once you're familiar with interpreting the confusion matrix, your life is super cool as a data scientist. Okay. And once you interpret this, the next step is, oh, my model um, my model did not classify correctly. A lot of misclassification values are there. Hence, my model requires fine tuning. That is the next step. First step is you need to clean the data and then you need to split the data in training and test data set. Next one is you need to train your model with the training data set and then you apply the trained model on the tested data set, which is a new data set. And then the next step is you need to measure your model's performance. Okay, how well my model distinguishes between churners and non-churn. It's something like good person and a bad person, how well my model distinguishes. And especially the confusion matrix is really helpful to understand how well my model correctly identified the good person as a good person, bad person as a bad person. Got it? So that is what the confusion matrix. Don't worry about this command, all the things, okay? Just understand the big picture now. The commands and all, you can learn it later. So as I told you in the previous session, most of the customers, they already have the script. But you should know, you should understand completely that script. And you should simply pass the arguments. That's all, okay? Since you don't have to worry too much about that, okay? And anyway, it is required, but still, right, at this moment, understand the big picture, okay? And here, yeah, display predictions and properties for a few test samples. This is also I did it for you guys to understand clearly. And what I do is I'm going to hit the run button. Let us see what happens. Look here, my model predicted everything. It did everything. 1 second. It got executed successfully, no error. We trained three different machine learning models: logistic regression, and what is the accuracy. So these are the various metrics, guys. It's something like a human. We have different parameters, right? Vital parameters like heart rate, blood pressure, and sugar. Similarly, right? With these three things are good, then it's considered right. Our vitals are normal. Similarly, right? Here three metrics are there: accuracy, AUC score, log loss. It shows the accuracy is 0.81. Very good. It's somewhat closer to 1. Any value closer to 1 is better. Okay. And AEC score is zero point 0.6 is really great. Okay. And log loss is 0.39 is good. The error is less. Log loss means no, so it's good. And next one is precision, recall, FN score, all the things we can see here. So 0.85 for the non-churners, the precision is 0.85 the recall is 0.91 and the FN score is this one. Whereas the churn, we are interested in churners than the non-churners. Why should I worry about non-churners? I'm very particular about churners because they are going to leave my business anytime. If I know well ahead, if my model detects more number of people that they are going to leave my business, which means the churners, that will be really helpful. But here, these values are not that impressive. Okay, but F1 score shows 0.62. It's kind of okay. 0.69, 0.56. This is your precision and recall for your non-churners. Okay, fine. Anyhow, we discussed in detail each and everything in the previous session, isn't it? So you watched that video, okay? Anyhow, we'll discuss it little later. And then I'm using something called cutoff here. Okay. So what is cutoff here? We discussed about cutoff in detail. What do you mean by cutoff? Why do we have to use cutoff? That is what my question now. Only one correct answer. Very good. Very good. Priya, you are correct. Why do we have to use cutoff, guys? Hmm. No, no, no. Cutoff is not applicable only to logistic regression. It is applicable to almost all the algorithms. Okay. Cutoff. Don't get confused. Okay. Hmm. Any other? Okay. Yeah. See, the cutoff is right. Let's say in the case of logistic regression, the output is a probability, isn't it? 0 and 1. I told you the value is anywhere between 0 and 1. That means, for example, Ashok Kumar, my model predicted the probability as zero point 0.9, which means he is more likely to leave my business because the zero point 0.9 is very closer to 1. Okay. And to make a final classification, what we do is we define a threshold or the cutoff value to decide, right? If the probability is greater than or equal to the cutoff value, we classify them as the churners. Yeah, who mentioned about binary classification? Yeah, very good, Roshan. Binary classification. In the case of binary classification, that we do it. So if the probability is greater than or equal to the cutoff value, we classify those customers as one. That means those customers are going to leave. So that threshold cutoff value you need to decide. So like I said, zero point 0.9 is is very closer to one. Hence those customers are more likely to leave my business. Or let's say, if your business is very sensitive, right? For example, you want to find out the probability, like, 0.7. Those customers' probabilities 0.7 above, they are more likely to leave my business. For example, Rajesh and Kumar, Mahesh, these customers' probability, my model predicted the probability as 0.7 and above. So what I do, right? I just say those customers, my model predicted 0.7 and above, you flag them as 1. You label them as 1. That means those customers are more likely to leave my business. Rest of them are non-churners. Again, this cutoff value, the default cutoff value is 0.5. This is very important. The interview they'll ask you. So the default cutoff value is 0.5. Default cutoff is 0.5. Okay. For example, like I said, Ashok Kumar, listen, 3% ABC. The model predicted the probability as a 0.72 and 0.70 and 0.90. So for since these three customers, probability is zero point 0.7. My cutoff is 0.7. I just say 0.7. That means those customers, probability is 0.7 and above. You flag them as 1. That means these customers are more likely to leave my business. Rest of the customers I just put 0, 0. This cutoff value you need to decide. You need to have the domain knowledge. Okay, you need to decide. So you need to you need to be very careful about the cutoff value. For example, if I keep the higher cutoff value, what will happen? If I keep the cutoff value lesser, what will happen? For example, in the case of fraudulent transaction, you are working in a bank, fraudulent transaction. In this case, if you keep cutoff 0.7, only those transactions, the probability 0.7 above, you flag them as fraudulent transaction. What if the probability is 0.69? Do you consider that even though it is a fraudulent transaction, you consider it as a non-fraudulent? Then you are in trouble. In that case, you need to choose a lower cutoff value. Lower cutoff value. In the case of fraudulent, 0.5. Okay. So now you got a fair amount of idea about cutoff. Okay. How do I use it here, the cutoff value? In this case, okay, I just show you here. In this code, okay, here I mentioned about the cutoff here. One second. Look here, title, confusion matrix 0.5. So this is a default one. Default cutoff value is 0.5. And here, and then, yeah, I did not use anything beyond that. So 0.5 is your default cutoff. That is your baseline model. You just think that way. Look here, my random forest algorithm, confusion matrix, this one. And we are using three different models: logistic regression, and then the random forest, and then the XGBoost. And each algorithm for with the 0.5, the default cutoff 0.5. So how well my model classified? So this is your actual, the row side is your actual, and this is your predicted value. Okay, in this case, 0 means non-churners. They are not going to leave your business. Okay, so 0, the predicted is also 0 here. I just write it one more time. This is 0 and 1. This is the one is predicted by my machine learning model. Okay, this is the one predicted by my model, and actual is the reality. Okay, as per the record, are they churners? The 0 is churners, sorry, non-churners. They are not going to leave my business. Actually, they are not churners, and my model also predicted as 0. That means they are non-churner. 941 customers, my model correctly predicted as a non-churner. Very good. Like Priya asked, right? So why should I worry about this? I'm very particular about churners. This is non-churners. But the confusion matrix gives all the four different values. True, positive. This is called your true positive. Okay. And then next one is the true negative. The true negative is the our area of concern, right? This is what we are interested. how many number of customers my model correctly predicted as a churner. One means churner, right? One means churner. Here on the left side, you can see one here. The first row was non-churner. This is the churner. Actually, they are churners. My model also predicted as 209 customers as churners. This is good. My model detected more number of churners. This is what we are interested. But unfortunately, when you see here, 164 is there. If you look at this one, you can see 164. What does this tells us? I just move this up. Yeah, 1 second, Priya. I'll just move this up. Okay. Yeah, here you can see 164 is there. But here, the row wise, if you see here, actually churners. But here 0 is there. My model wrongly predicted the 164 customers as a non-churners. Actually, they are churners, right? One means churners. But in the first column wise, if you see, the model predicted 0 for the 164 customers. So what does that mean actually? Actually, 164 customers are churners. The model wrongly predicted they are not churners. That means actually, they are bad customers, right? But my model wrongly predicted they are good customers. Ideally, this value is supposed to be here. So 360 and 73 or something like that, right? I think this one's supposed to be here. And next one, if you see here, 95 customers are actually churners, but my model wrongly predicted churners. It's something like this, guys. In the case of court, if the judge gives a judgment, like, 95 people are, 95, or let's 164 people are innocent. Actually, they are not innocent. They're criminals. What will happen? If you allow them to walk in the public, what will happen? There is a major catastrophe. Okay. And similarly here, actually the 94% are non-criminals, but my model, my judge gave a judgment that these 95 people are criminal. In the case of the court's verdict parlance, this is both of them are very dangerous, isn't it? If you say a criminal as a non-criminal, and if you say a non-criminal as a criminal, both of them are dangerous, isn't it? So the whole objective here is you need to reduce this as less as possible. Okay, you cannot make it 0. You can, but I know. So even 1%, if the model wrongly predicts the good person as a criminal, it's a very dangerous. We cannot afford, right? So that's the reason why we need to decide the cutoff also. We need to decide the cutoff also. What cutoff can I use it? Cutoff will vary from the business to business. Okay. The next question is, yesterday you sent out the question, Priya. She asked about how do I choose the optimal cutoff value? There is a separate thing that I will discuss about later. There is a custom, you can come up with a custom cutoff value. How do I come at that? There is a formula for that. I will let you know, little later. Don't worry. So now you understood how to interpret the confusion matrix. Just beneath that, look here for you guys to understand, right? If the model predicts the probability, and say these are the columns in my data set, the test data set, customer ID, gender, all the things, and along with that. I write, so the finally, right, you have, because so many columns are, that's why 3 rows it comes, right? So it wrapped up in 3 and 4 rows. And finally, you can see the predicted class. Okay, I included the predicted class along with the columns. Okay, along with the data set, along with the columns given by my customer, I included the predicted class also. For example, the first customer, who is he? The customer is 1811, right? For him, the predicted class is 1. That means the customer is going to leave my business. Okay. Along with the predicted class, I included the probability also. Okay, man, the customer is going to leave. Your model predicted the customer is going to leave. What is the probability that the customer is going to leave? So the model predicted class is 1 or 0. 1 means they are going to leave your business. 0 means they are not going to leave your business. Fine. For 1 is they are going to leave my business. Fine. What is the probability that they are going to leave? There is a 0.78. If you round to 0.8, right? There is a 0.8 probability that customer is going to leave. and this customer, point 0.007, there is a less likely chances that he is going to leave, and even this guy is also less likely to leave, and 0.71 is going to leave. Okay, again, it depends on your affordability. For example, you just think, right, if the probability value is point 0.9, if you take it, let's say you are into Airtel business, 25 million customers are there. Out of the 25 million customers, even if you take 1%, how much? It's a big number. Do you think practically you can call the 1% of 25 million customers, those are more likely to leave your business and convince them? That's not possible, right? So for that reason, also you choose the cutoff value, zero point 0.9 and above. Okay, you just flag them as one. Okay, but here what I did, you display the predicted class. Okay, and then the probability also along with that. So one means the customer is going to leave, and what is the probability part? There is a zero point 0.8, almost zero point 0.8, right? So compared to this one, the risk is very. This customer is, we need to contact them immediately. Zero point 0.8 probability. This customer is 1811 is going to leave. So I just displayed this value also along with this, so that when I share this script, right, you need to execute this. When you execute this, you will be able to understand. Okay. Next one is, yes, for each and every algorithm, I display the accuracy along with the AEC score and log loss, and even the classification report also. And if you scroll down here, you can see all the things here. Okay, fine, everything is good. Fine. The next one is, I just skip this one because that is the one I executed a while back. And I just, next one is the hyperparameter tuning. Okay, next one is hyperparameter tuning. So what do we do as part of hyperparameter tuning? Like I said, right, so let's say, the simple example, what exactly hyperparameter tuning? How many of you are aware of the micro oven? How many of you have micro oven at your home? At least you know what is micro oven, right? For example, you want to cook your chicken. Let's you wanted to have a oil-free chicken fry. You put all the masalas in your chicken, right? And then what you do is, you keep it inside your micro oven, and then you set the time, grill time or something like that. 25 minutes or 30 minutes. What will happen after 35 minutes? It will get fried. So no oil, nothing. You can take it and then you can eat it. But here the question is, how much, how much value should I set it? Can I keep it for 25 minutes or 24 minutes, 23 minutes or 20 minutes? At which temperature? Okay, it will get cooked. If it is overcooked, also problem. Undercooked, also problem. At what temperature, or how many minutes it is actually required in order to cook the chicken, so in a very tasty manner, right? So in that case, right, so you will need to decide, what time duration that you need to keep it. Okay, so it's a simple analogy for the hyperparameter tuning. Okay, so okay, so now what we are doing is, we are doing hyperparameter tuning. This is basically to improve your model accuracy, guys. Okay, and then here I just define the param grade. Okay, what is param grade? So here, you can give any name. So inside of this, right, param grade on the right side, I mentioned the dictionary, number of trees. Like I said, random forest, it uses minimum 10 trees. The more the number of trees, the model accuracy will be good, and the generalization of the model is very good. Now the question is, how do I decide how many number of trees are required? The default one is 10, but you said more the number of trees, the accuracy is good. Can I keep it 50, 100 or 200? If I keep 50, what will happen? I will just check my model accuracy with the 50 trees generated by model. With that, what is my accuracy? And again, you need to manually change your number of trees in your random forest. Let's say you set 100. Again, you need to check the accuracy. Instead of checking one after the another manually, what we are doing is, we are creating a grid. We are giving all possible combination of values. With the 50 number of trees, what is the accuracy? You test it once, and then with the 100 number of trees, you test it. What is the accuracy? With the 200, what is the accuracy? You just test it. Okay, and then what is the accuracy? With which number of trees my model accuracy is good? For example, if your model accuracy is zero point 0.9, which is closer to 1 for the 100 trees. When you used 100 trees in your random forest, the accuracy came closer to 0.9. But when I used 200 rays, the accuracy was not a point in, maybe 0.86 or something like that. But when I used 50, it may be right 0.82. But when with 100 number of trees, it gives the, so using, it's kind of a trial and error. Try with 50, try with 100, try with 200. Like a car example, right? Which one gives a more accuracy? Like I tried three different models in one go, and of the three models, one car gives me better mileage because my objective here is better mileage. Here in this case, similarly, our objective is higher accuracy. Okay, with how many number of trees? So what value should I use it? How do I find out? So using hyperparameter tuning, we are defining the grid initially. As part of the grid, we specify all the possible number of values. Similarly, maximum depth. I explained what is maximum depth, right? The minimum sample split. We try with, we say different possible combination of values. First, it start with the 50 number of trees and maximum depth 5, and then sample split is 2. With this combination, what is the accuracy? And then it goes to the next one, 100, 10, and 5. And similarly, 200, 15, and 20. With this three different combination, it will check it. And whichever combination, the model accuracy is good. So it will say here that is the best model. Look here, there is something called GridSearchCV. Okay. There is yeah, N estimate is the number of decision trees in the forest. Okay. Priya, okay. Max depth is that is the one controls how deep each tree grows, and minimum sample split is nothing but the minimum number of samples required to split a node. Okay. So what is a GridSearchCV? So here is how you can understand the GridSearchCV, right? So it helps us to find the best parameters for your random forest model, even for the XGBoost model also. Okay, and it defines different parameters, hyperparameters, and also it uses five-fold cross validation. You remember the cross validation I explained to you previously. It performs five-fold cross validation, and then it scores it gives us the AUC. See, AUC, as I told, right? Simple, guys, very simple. If you understand this one, this will make your life simple. See, if I train a model with 50 decision trees, and each tree, the maximum depth is 5 and 2, what is my AUC value? AUC is your accuracy, right? AUC value is less than 0.86, which is closer to 1. Any value which is closer to 1, that means the model accuracy is good. Fine, but with this combination, 100, 15, 5, with this combination also, it finds out the AUC for this. For this, let's 0 point, let's say 8, 9. Okay, and then with this combination, 200 and 15 and 10. With this combination, my AUC is let's 0.87 only. Okay, not up to the mark. So this one is very closer to 1. Hence, if I use the grid search CV, what it does is, right, it tries all the possible combination of values, and finally it lets us know automatically, hey, guys, with 100 trees and 10 maximum depth, and then the 2 minimum sample split, the AUC is very high, right? So, and rest of them A is not up to the mark. Hence, you use 200 trees and the maximum depth is 10 and minimum sample split is 5. That is how it tells us. Look here in the grid search CV, I specify the random forest classifier and param grid. This is what I'm passing all possible combination. CV is cross validation. Okay, 5, and AUC score. We need to tell what kind of metrics that you are going to use it. N underscore jobs equal to -1, it's a parallel tasking. Okay. So build the tree simultaneously. Okay. And verbose to, right, whatever you do it, you just display it in the screen. And finally, this output will get stored in a variable called this one, fit. Here, what we are doing, right, you take the training data set in input feature and training data output feature. You are passing it as an argument to train your grid search CV in 5-fold. And then we are noting down the time also. Okay. Random forest, right? It's the best parameters. This is very important, guys. In the interview, they'll ask you, how do you find out the best parameter values? I'll be using a grid search CV. And for the grid search CV, inside the grid search CV, I mentioned the type of the algorithm. In this case, random forest, or you can use XGBoost. Okay. And then what is the parameter grid, right? So, and then that's all. So what will happen is finally, I'm going to fit that one. When I fit that, what will happen is it'll have we have there is a built-in variable called best underscore params underscore. This is the one will give you of these three different combination of or possible combination of values, which value is best. For example, 100. Okay, so it gives you automatically 100. Okay, and just for example, I'm saying, right? So 100, it can be 200 or it can be 50 also. Okay, and next one is how much time it took to do this one. So hyperparameter tuning, especially in the case of GridSearchCV, is one of the techniques. It takes longer time, okay, to do the because it has to try first. It has to build the 50 trees and maximum depth of 5, and then minimum sample split 2. With this, how my what is the AUC? It has to find out. 100 trees it has to build. It's a time-taking process. For that reason, I just noted down the start and end time. If you subtract the end time from your start time, you'll get to know the elapsed time. Okay, how much time it takes, and then I'm using there is like best params. There is something called best estimator. Okay, what this one gives us? Hey, I cannot test each and everything manually. I will leave it to you guys, GridSearchCV, who you test with all possible combination of values. For example, if you find 100, 10, and 5, you take that, you give me that and put it in my model. Okay, put it for a random forest classifier inside the parenthesis. Number of trees is 100 and maximum depth equal to 5. And then you fill up all the values. You give that. You find out the optimal number of values and you fill up this one. And then finally, using the best estimator, if I give that, it gives me the model which uses the optimal number of values with that the highest accuracy, right? AUC, that one it gives you. With the best estimator, what we are doing, we are predicting the probability. It's something like you are trying three different types of cars. Of the best cars, right? Let's you are trying 10 different cars. You don't remember it, right? So you leave it with GridSearchCV. Hey, you try all the 10 different cars, you drive it, and then you tell me which car's mileage is very good, everything, mileage and the torque thing, and then all the things you test it out, and then you give me the final thing. So the best estimator will give you what is the possible combination of values. We can use it as an hyperparameter to my model. And with that thing, right? Yeah, sorry. So that is the one is my best model. Okay. For example, 100 trees and 5 maximum depth, 2 minimum sample split. So with that combination, my model AUC is very good. So what you do is you can use that as a best model, best random forest model. Okay. And then with the best random forest model, you predict probability. Okay. And then you plot the ROC AUC log loss. And then similarly, confusion matrix, everything you can put it. And finally, next one is same way you do it for XGBoost model also. The same process applicable here also. For random forest and XGBoost, and what is the accuracy? We can see it here, right? So 0.5 cutoff. And with random forest, all the finally, if you go down here, I'll just tell you that one. Sometimes, right, not all the time top down will help out, right? Look here, I compared all the models. Logistic regression, and then without hyperparameter tuning, random forest, XGBoost, the model accuracy is not that good, isn't it? Logistic regression is doing really good, 0.86. And after I did the hyperparameter tuning for the random forest, best XGBoost, now it comes 0.86, 0.86. Good, right? So now we compared at the end, which model is really doing good with the baseline model in the sense without using the hyperparameter for the random forest and XGBoost, the accuracy is not up to the mark. With that, we cannot decide. After I did the hyperparameter tuning, I could see that all the three models, logistic regression and then best random forest and best XGBoost, are really doing good job. Okay. Next one, what I did. So now you understood, right? Next, what I do here is, see, in this case, what I do, I'm using different cutoff. The default cutoff value is 0.5. Look here, I'm using 0.60 and 0.70 here. Okay, with that cutoff, Yeah, 1 second. I need to execute this one. Let me see if that one works. Yes, very good. So we can see that logic at zero point 0.6 with zero point 0.6 cutoff, how much, it detects the, see now it got reduced 157 churners, right? Our objectives, we want more churners, but it is also reduced here with zero point 0.7, zero point 0.6, okay? And 0.90 is random forest, best random forest, and best random forest is 0.36, and XGBoost is 160, yeah. XGBoost is really good, point point 0.7 with different cutoff. Also, we found this one, right? So now with different cutoff, we can see that, yeah, this is a base model. Okay, is what we can say. Yeah, that's what. This is how you can find out the best cutoff value. Okay. With see, it's not only about hyperparameter. Which combination of parameter my model accuracy is good? You need to identify it. Of the three models, which model is best? To determine that, you need to do the hyperparameter tuning. After you did the hyperparameter tuning, which model is really doing good? We have seen it, the logistic regression, XGBoost, and random forest. These three of them are doing good. But now the question is the logistic regression. In that case, see, in the case of logistic regression, I don't have to do too much of hyperparameter tuning. The remaining thing, I need to do a lot of hyperparameter tuning. Even though I spend a lot of time in terms of doing hyperparameter tuning for random forest and XGBoost, it is almost same as the accuracy is same as my logistic regression. Why should I break my head? That's the next question. See, in the case of huge volume of data, the training takes longer time. So in that kind of situation, the random forest and XGBoost is really helpful. If you have huge volume of data, we are talking about just maybe, right, 40,000, 50,000 records in this case. The real world scenario, we are dealing with the petabytes and above. Or, let's simple example is 50 million records are the history data, right? For past history data, 50 million or let's 100 million records are there. So in that case, if you use logistic regression, it takes longer time. When it comes to the ensembling method like XGBoost and random forest, it does the parallel processing. Parallelly, it constructs the trees. Simultaneously, it constructs the trees. Hence, we cannot decide just because the accuracy is good with logistic regression, we can simply go by logistic regression. Okay. But if the accuracy is almost same for all the three models, which one should I choose it? XGBoost is really good because as I explained to you in the previous session, the internal workings or the mechanics of how the XGBoost works, right? The XGBoost, what it does is the idea of XGBoost is first it starts with a simple decision tree, weak model, and then it randomly makes the guess. Okay, it makes some mistakes, and then the second step is it builds us another tree. That tree will fix the misclassification done by my previous tree. Similar, right? So this one, the second tree will fix all the misclassification done by my first model. But still, right? It will fix it, but it will not fix everything. Still, it will left with a few misclassification. To fix that misclassification, it will create another model, decision tree model. That one will fix the leftover misclassification by my second decision. That's what I explained, right? So in this case, what happens is each tree in my XGBoost trying to fix each and every tree's mistakes until all the errors will get reduced. So in that case, the XGBoost is really good, and at the same time, when it comes to real world data, huge volume of data, the XGBoost is really good in terms of accuracy and in terms of performance also. Okay, the next one is now that you understood, what I will do is I will share this script with you all with the data set. You can give it a try and then you explore it, and then I will give you some simple assignments. As part of this one itself.